Welcome back to Advanced Physics Explained. Here's a classic mechanics problem. We have a square metal sheet, 6 centimeters by 6 centimeters, and attached to its right edge is an isosceles triangle with base 6 centimeters and height 6 centimeters. Our task is to find the center of gravity of the whole composite shape. Before we go step by step, pause the video and see if you can work it out yourself first. To solve this, we start by locating the centroid of each individual shape. Centroid is simply the geometric center of a shape. In 2D geometry, it is the point where the shape would balance perfectly if it were made from a uniform material. For a square, the centroid is at the intersection of its diagonals, which is right at the center. Let's call this point G1. That's 3 centimeters from the right edge. For the isosceles triangle, the centroid is the intersection of the 3 medians. A median is simply the line that connects a vortex to the midpoint of the opposite side. Therefore, the centroid lies 1/3 of the way up the median from its base. Since the base is 6 centimeters, and the height is also 6 centimeters, the centroid lies 2 centimeters from the base along the median. Let's mark this point as G2, at 2 centimeters from the base of the triangle. Now let's join the edge of the square and the base of isosceles triangle. Notice the line between these two centroids G1 and G2. The new center of gravity of the entire composite sheet must lie somewhere along this line because that's where the balance of mass occurs. Let's say the new center of gravity is at point G, but we do not know the exact position, therefore we will just give it distance x centimeters from G1. And since distance between initial centroids is 5 centimeters, we can also say that new centroid is at distance 5 minus x centimeters from G2. Now we can determine position x simply by using principle of moments. The idea is simple. The clockwise moments equal the anti-clockwise moments about the new centroid. Let's picture this like a rod on a pivot. Pivot represents the centroid, point G, while the ends of the rod having G1 representing the whole mass of the square, and G2 representing whole mass of the isosceles triangle. Moment is calculated as the product of the applied force and the perpendicular distance from the force to the pivot point. Before we continue, we have to find mass of the square and triangle separately, which will signify the acting forces since the objects are acted upon by constant gravity throughout. Starting from the general formula, mass equals density times volume. For a thin uniform sheet of thickness T, the volume is area times T. Since thickness and density is uniform throughout, their values are constant, and hence mass is directly proportional to the area. Now let's find the area of each object to get the final masses. Now the principle of moments states that the sum of all clockwise moments about a pivot point is equal the sum of all anti-clockwise moments about the same pivot. Solving gives x about 1.67 centimeters. So the combined centroid, G, lies 1.67 centimeters to the right of the square's center. The square being heavier keeps the center close to it. You can also determine the value of x using the principle of center of mass. You can draw x and y axes anywhere in this figure, but to keep it neat and easy, draw at the center of the square and find the value of x using this formula. Try to solve it, and compare if you also get x equals to 1.67 centimeters. If you found this explanation clear and helpful, don't forget to give it a like, share it with your friends who might find it useful, and hit the subscribe button so you don't miss future lessons. And of course, tap the notification bell so you'll always be updated when a new video comes out.